Hi everyone, I am Deep. I'll be presenting our work adaptive sample selection for robust learning under label noise. Let's look at the problem formulation. So typically deep networks require huge amounts of training data, and this is collected through, say, crowdsourcing or automated web crawling and so on. This inevitably results in labeling errors. So what we are given is a set of data points xi with possibly noisy labels as a yi. So we are given this noisy training set as eta. We want to use this to train our network such that it performs well only on the set S, which is the same data xi, but with the clean labels, the true labels instead. This, in a nutshell, is the problem of robust learning under label noise. In principle, we could tackle this problem if we knew this quantity eta xij, the noise rates, which tell us that given a sample and its true label being I, what is the probability that this label got flipped to some other class J? Of course, in practice, we do not have access to these eta xijs, so several methods have been proposed to address this problem of label noise in spite of the lack of this knowledge. A recent and popular approach has been that of sample reweighting, which is inspired from this observation that the neural nets learn from cleanly labeled data before overfitting to the noisily labeled data. And the idea here is just like in a curriculum learning setup, inspired by this idea, you assign binary or real valued um, weights to the samples during risk minimization to reduce this overfitting. A popular heuristic is to compute sample weight as a function of the loss value of that sample. Stemming from our observation that sample loss values keep on changing throughout the training and that too differently for each class, we propose to use statistics of the loss values of the samples in any given mini batch to then guess whether a sample has clean labels or not. So I feed this data x comma yx to my neural network where yx are possibly noisy. And for each mini batch, what I do is I take a look at the loss values across these samples in mini batch. For each class I separately, I then compute loss statistics for each of the classes separately to then deem whether yx is clean or noisy as per the network given the current state of learning. Collect all such deemed to be clean x comma yx pairs, and I use only those for my parameter updation. This is the outline of our proposed algorithm. We empirically show that our algorithm has comparable or better test set accuracies on cleanly labeled data, is consistently and reliably identifying the cleanly labeled samples as well. So this can be seen in all the three plots where higher the better, and our algorithm corresponds to the blue color here. In conclusion, we have proposed an adaptive sample selection scheme which uses class-wise statistics of the sample loss values. We do not need any knowledge of noise rates, extra clean data, or training multiple networks, and we have shown empirically on par or improved performance. Thank you.